Hey everyone, welcome. 4.2 Complex Solutions of Equations. What we're going to look at, fundamental theorem of algebra. You don't need to know what it says because I'm just going to paraphrase it for you. It says that any polynomial with an nth degree is going to have n solutions. It can be real or complex, so they don't have to just be complex or just real. And you've seen that before. So for example, if x to the first minus 2 equals 0, the degree is 1, so that means there's going to be one solution. X is 2. If it's x squared, it's the 2, second degree, it should have two solutions. They may be real, they may be complex. And what you can do if you want to solve that, we're not going to spend a lot of time, but you can use the quadratic formula of ax squared plus bx plus c equals 0. Here's the quadratic formula. So you can find the solutions, and remember the discriminant will tell you if they're real or they're complex or how many solutions you'll have. I'm not going to spend a lot of time on that because I think you pretty much know how to do that. What I want to focus my time on is what happens if x to the third, x to the fourth, x to the fifth. This one should have three zeros or three roots or three solutions. This one will have 4, this one will have 5. They may be real, they may be complex, and that's why we're doing it in this section. Here's the first bit of good news as far as complex numbers. This is not something you have learned before. Complex solutions occur in conjugate pairs. So if you know how to find the conjugate of a number, you found not only one, but two solutions. All right, and here's how it works. If a plus bi, where b does not equal 0, because if b equals 0, it's not a complex number, is a solution of a polynomial, then a minus bi is also a solution to the polynomial. So we're going to say also, not also. Also. And there's a little asterisk here because it must have real coefficients. So x minus I equals 0 is not going to be the polynomial we're looking at. We're looking at things like this one. We're looking at this type of equation. Or we're looking at some other ones that I'm going to show you right now. So here is the first example we're going to look at. It's going to be solve x to the fourth minus x squared minus 20 equals 0. So first of all, you should say how many solutions are you going to have? 4. Are all of them going to be real? We don't know. So let's find out. What I'm going to do first is let's do the magic x. Because I have 1, 2, 3 terms, the magic x will work. And they're in descending order. It's going to be very nice. So what numbers multiply a times c? 1 times negative 20 is negative 20. And the middle number is negative 1. So what numbers multiply to negative 20 but add to negative 1? Negative 5 and 4. And since it's a 1 and a 1, I don't have to do any reducing, and I'm ready to go. Now, it's not just going to be x. It's going to be x squared minus 5. So we've got x squared minus 5 times x squared plus 4 equals 0. So now I can make this one x squared minus 5 equals 0, and x squared plus 4 equals 0. So add 5 to both sides, and then take the square root. I can say x equals square root of 5, and x equals negative square root of 5. Don't forget the positives and negatives when you take the square root. That's where two of our answers come from. Now we're going to do the same thing on this side, and I end up with x squared equals negative 4. When I take the square root, I end up with x equals plus and minus the square root of negative 4, which you know is 2i. So x equals 2i, and x equals negative 2i. These are complex conjugates of each other. This one's a positive, this one's a negative. Just because there's no number in front, it's 0 plus 2i and 0 minus 2i, so they are opposites, which holds to what I had said earlier. So there are my 1, 2, 3, 4 solutions, and we have 4 solutions, so we found all of them. Good. Now let's do this one. Find all the zeros of this function, given that this is 1, 0. So I'm telling you, you've got 1, 0. And since it's complex, I really have told you, you've got 2 zeros. That is, x is going to equal 1 plus 3i, and x is going to equal 1 minus 3i. So we found 2 of the 4 possible. It's always the highest number, 3, 2, 1, 0. Okay, so 4 is the highest. So what I'm going to do is, if this is a 0 or a root, remember when we plug in things to functions, inside the parentheses move it left to right, and these are zeros or roots, so that means I can say x minus 1 plus 3i is 1, 0, and I'm also going to do x minus 1 minus 3i. And I'm going to multiply those together. That way I can figure out what does this look like, because if I'm multiplying these two things together, the i's should cancel out. So what I'm going to do is I'm actually going to rewrite this as x minus 1 plus 3i. And I'm running out of room. Let's see if I can get it in there. And it's going to be x minus 1 parentheses plus 3i. And this one should be minus because I have to distribute the minus to both of them. So that should be a negative 3i. You can't really see it. I'm going to rewrite it. I kind of shouldn't have put it over there. So I have x minus 1 in parentheses plus 3i plus a negative 3i times x minus 1 plus 3i. So if I multiply these together, because this is a minus and this is a plus, these two are actually conjugates. So when I FOIL, the O and the I are going to cancel out. So what I'm going to do is x plus 1 times x plus 1. I get x minus 1 squared. And then the O and the I cancel out. And then I'm going to do the last one. Negative 3i times 3i is negative 9i squared. Negative 9i squared is really just going to be plus 9. So I've got x minus 1 squared plus 9. Now if I just do this one real quick, negative x minus 1 squared is x minus 1 times x minus 1. I get x squared minus 2x plus 1 plus 9. So I can rewrite this whole thing as x squared minus 2x plus 10. So that is going to be my two solutions. Now why do I really do that? Because what I'm going to do now is I'm going to take my function and divide it by this to see if I can find my other two zeros. So I have x squared minus 2x plus 10. I'm going to divide my function that I have by this, which is x to the fourth minus 3x cubed plus 6x squared plus 2x minus 60. Alright, so what do I have to multiply x squared by to get to x to the fourth? I have to multiply it by x squared. I'm just going to write it above here, that way I know where I'm at. X squared times x squared is x to the fourth, and then I do x squared times negative 2x is negative 2x to the third, and x squared times 10 is 10x squared. Now what we do is subtract down, and these cancel out. Negative 3 minus negative 2 is really the same as adding 2, so that's going to be x cubed, and then 6 minus 10 is negative 4x squared. Now, I want to do the same thing again. What do I have to multiply x squared by to get to x cubed? It's going to be a positive x. So x times x squared is x to the third. X times negative 2, oh, and I forgot, I got to drop this one down to be plus 2x, sorry. And then I did x squared times, x times x squared, I got this. X times negative 2 is negative 2x squared, and x times 10 is plus 10x. Let's go this way and subtract down, these cancel out. Negative 4 minus negative 2 is going to be negative 2x squared, and 2 minus 10 is going to be negative 8x. Yes? And I'm going to subtract the 60, bring that down here. Now I have to say, what do I have to multiply by to get this x squared to match up with this one? It's going to be negative 2. So negative 2 times x squared is negative 2x squared. Negative 2 times negative 2 is negative 4x. And negative 2 times 10 is negative 20. Did I do that correctly? I don't think that I did. Okay, well, what we would do from here is you would say that x squared plus x minus 2 would be another set of solutions. We would set this thing that we get up here equal to 0, and then you would be able to say, there are my other two solutions. They may be real, they may be not. Alright, so here's your assignment tonight. See if you can find the mistake that I made in here. Good luck.